Calculus Kids, this is Dr. Callahan for week 5, Tuesday. Go ahead and pause the video and get started with your warm-up log. Okay, so today we're going to talk about the properties of horizontal and vertical asymptotes. This is a continuation of the skill that we talked about on Monday, and we're just kind of doing a second day to review the skill, and I will give you guys several examples of this. Normally, if you're actually in class together, I will have you guys do a whiteboard practice and you will write the score on the upper right-hand side of your whiteboards. But given the fact that this is a virtual learning day, we'll just pretend that we're going to do it as well. So you can do this either on a whiteboard or you can do it on a separate piece of paper. I'll show you a question, you pause the video, and then I'll go over the answer and see if you get it right. Okay, so try to practice at home in that regards. All right, so here is question number 1. Find all the vertical asymptote of this problem. And typically I have a timer right here, but given the fact that this is on a video, you can pause the video, and for sake of time, I'm just going to go ahead and go over the questions for you. So the vertical asymptote is somewhere on the graph, whereas your graph is drawn, and as you can see, this graph is going up to infinity, it is where it is not going to be defined. So then looking at this, how can I make this function not defined? It's by setting the denominator equal to 0. But before I do that, let's go ahead and solve for this or factor it out. I could do a positive 2, x minus 2, but then remember you have to factor the numerator as well, just in case you need to cancel something. So let's factor the numerator. What times that gives me a 2, but when I add it together it gives me a negative 3. How about a negative 2 and negative 1? Well, in this case, you can actually cancel the numerator and denominator. Now you only have one factor, so you're going to set it equal to 0, x equals negative 2. This is going to be your vertical asymptote, because when x equals negative 2, your denominator is going to result in 0, which is going to be undefined, and this is where the vertical asymptote is going to be, except it's going to be over here, where it's negative 2, not positive 2. If you want to take a look at the steps, here they are. And we will proceed forward. Okay, so this one says determine the limit as x approaches 2 from the left and 2 from the right for this function. You can go ahead and use a table of content. If x is approaching 2 from the left side, you can use 1.9 or 1.99. When you plug this into this function, you're going to get a negative 29. Now, to be consistent and make sure the number is consistent, you can try x approach 1.999 from the left side. And when you plug it in, you can see that you have a really big jump here with your number. So you can assume, given the fact that it's a pretty big jump, if I were to use 1.9999, I will get a negative 29999. So I'm just going to say it's going to approach negative infinity as x approaches negative 2. Oh, I'm sorry, positive 2 from the left side. Then you can do the same thing with the right side. You could say, well, as x approach 2.1, you can go ahead and plug that in. As x approach 2.001, plug that in. X approach 2.0001, you will find that it will give you a positive infinity. So is this limit continuous? It's not, because this is a discontinuous limit. As it approaches from the left side, it's negative infinity. As it's approaching from the right side, it is positive infinity. So if this is my graph, and here is positive 2, And this is my vertical asymptote because x cannot equal positive 2. And as x approaches 2 from the left side, it is going to go to negative infinity, so it looks something like this. And then as x approaches positive 2, it's going to go to positive infinity from the right side. So it looks something like that. All right, try the next one. You can pause the video. All right, let's take a look at this one. So as x is approaching negative 3 from the right side, you can go ahead and try some numbers like negative 2.9. And I know sometimes it gets a little bit confusing depending on whether you're approaching from the left side or the right side. So I sometimes just like to draw a diagram so I can visually see if I'm picking a number on the left side of it or the right side of it. So if this is negative 3 and I am approaching negative 3 from the right side, here is 0. So my number has to be smaller than negative 3. So it would be negative 2.9. I know that's kind of counterintuitive because if you're approaching 3 from a positive 3 standpoint, as x is approaching from the left side, it will be a 2.9, not a negative 2.9. So I sometimes just like to draw this. And then vice versa, if you're approaching negative 3 from the left side, it would have to be a bigger number, a bigger 3. So negative 3.01 perhaps. So visually you can see that. And as you can see, as x approaches negative 3 from the right side, you get a negative infinity. And similarly, if you approach it from the left side, you get a positive infinity. I think we probably have enough of that. So let's go ahead and proceed with the next one. Okay, and then just a quick little check. Let's talk about horizontal asymptote. With horizontal asymptote, remember there are 3 different conditions. If the exponents are exactly the same, like 2 and 2, then you just look at the leading coefficient. So in this case, y equals 2 will be my horizontal asymptote. If the denominator has a greater exponent, then my horizontal asymptote is y equals 0. And vice versa, if the numerator has a bigger exponent than the denominator, then the the horizontal asymptote is y equals does not exist, or there is no horizontal asymptote. So let's practice with that with this example here. So whenever you say as x approaches infinity, find the horizontal asymptote using the 3 rules. Okay, so looking at this part right here, you can see that the bottom has a bigger exponent. So therefore, my vertical asymptote is just my horizontal asymptote is just going to be 0. That's the easiest way of doing it with the 3 rules. Now, if you're like, I need to know algebraically why that is the case, what you can do is you can go ahead and take a look at the biggest power, which in this case is x to the 3rd power, and then divide that on every single term. So here, 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 all 4 of these divided by x to the 3rd power, like I did right there. And then what you can do is you can go ahead and start canceling some of this. You know, if you have x to the 3rd power, it's 3x's, x squared is 2x's. So what you see here is that you're going to have a pretty small number on top and a very big number on the bottom, because as you go ahead and cancel the x's, you still have 1 remaining x on the bottom. When the top, the numerator is a 3, and as x approaches positive infinity, you have a really, really big number in the denominator. So what happens when you have a really small number divided by a really big number? It virtually kind of becomes 0. It gets very close to 0. So I'm just going to say this entire thing approaches 0. Similarly over here, you have 2 on top, but then if you have infinity in the bottom, or as x approaches infinity, it will be infinity times infinity times infinity 3 times. So essentially this will approach 0 as well. Then here, with the third one, you have x to the third, which cancels, and then this just leaves it as a 4, minus x cubed. And essentially, it's a very small number on top, or on the top, very big number on the bottom, approaches 0. So then what do you have left? You have 0 in the numerator divided by the number 4, which gives you 0. And that is your horizontal asymptote, algebraically. Now, the horizontal asymptote for this one, given the numerator is x to the third power and it's bigger, does not exist. If you're like, okay, but why does it not exist? Let's do this algebraically. What is the biggest exponent you see here from these 4 different terms? It's x to the third. So I'm going to divide all 4 terms by x to the third, just right here, 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 and here. So then again, you're going to algebraically cancel them out. X to the third cancels. You have a coefficient of 2 remaining. X squared over x to the third. Remember, once you cancel out the x's, so you have x, 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 x. So these 2 x's cancel out. Whoops. And then you're left with 1. 1 divided by infinity is going to give you essentially 0. And that's how we get 0. Same thing over here. You're going to end up with 3 divided by x as I approach infinity is going to give you a 0. And same thing here. Negative 2 divided by infinity times infinity is going to give you a 0. So then what ends up happening, you're going to have a very small number on top, which is just 2, divided by 0 on the bottom. So anything with a 0 in the denominator is going to result in does not exist. Although if you do use a small number like 0.00001, 2 divided by a very small number is going to be a very big number, and you could replace it with positive infinity. And I know you're like, but didn't you just say it does not exist? This is a little bit controversial because does not exist sometimes also mean it doesn't exist because you have a positive infinity, in that you can't definitively put in an actual number on positive infinity. And so therefore, something's wrong with my pen, it's not working. So therefore, it does not exist because you can't put a number on positive infinity. Okay, let's take a look at this one here. Now my pen is not working, but that's okay. I'm going to still continue on going doing this. 4x to the third divided by 5x to the third. They both have x to the third power, so that cancels. They're the same. So you just use the leading coefficient, which is 4 over 5. That is your horizontal asymptote. And again, if you take a look at this, if you were to do this algebraically, you will see that the second term and the fourth term results in 0, but then the first term and the third term here does have the leading coefficient of 4 and 5. So 4 divided by 5 is what you have. Then you have something that looks like this. If you look at the denominator, it's a square root of 5x squared. In our last lesson, I told you guys that if you have square root of x, if you convert that to radical form, from radical form to exponential form, it's x to the 1/2. So here, this is going to be a square root, but that square root is going to counteract with your 2, with your square. So that's going to cancel each other out. So essentially what's going to end up happening is that the square root and the square cancels. However, with your 5, that 5 still remains in the square root. So you have a square root of 5 on the bottom. Similarly, with this example over here, if you're looking at the biggest exponent, you have negative 2x 3 to the 3 over second power. Here you have 3x squared. So you're like, which one actually has a bigger power? Well, 3 divided by 2 is a 1.5, so you do have a bigger power in the denominator. So the denominator has a greater power, your horizontal asymptote will be 0. Here, you have exactly the same power, 3 over 2, 3 over 2, so you look at the leading coefficient, so therefore your horizontal asymptote is a negative 2 over 3. All right, guys, that's basically it. I hope you guys have a great day. I'll see you guys next time.